So today we are going to continue our studies in exponent properties, and I would like to wrap this up and tell you all the basics here in two videos. We had a part 1 and this will be part 2. So let's begin. Firstly, you have these two expressions. This is 2 to the third to the 2 to the 2 squared cubed, and this is also 2 squared cube. However, we have a parenthesis here, and that changes a lot because what is the difference between these? Well, if you see something like this without a parenthesis, you will have 2, and I mean that's not what you start with, because you sort of go backwards, and by backwards I mean like this. This is the way to solve it. So you have so firstly you will get 2 to the third, which is going to be 2 times 2 times 2, which is 8, and that's going to be 2 to the 8th power. So this is kind of our rule here. So if we would like to solve, let's say, something like 2 squared, so if we square this 3 times, once again we would like to solve this way. That's our rule here. So if we solve it that way, then what do we get? Well, we get firstly 2 squared, and this is 2 squared once again, which is 4. I hope you get the idea of it, or you can sort of start to understand it right here. And then we have 2, and what's 2 to the 4th power? Well, that's 2 times 2, that's 4, times 2, that's 8, times 2, that's 16. So that's 2 to the 16th power. So this is kind of our rule here. The little arrows represent the way you should solve it. Now, what does this mean? Right now, this is in a parenthesis, and that means that I cannot do the thing that happened last time, because firstly I gotta do this one in the parenthesis, which I can say that 2 squared is 2 times 2, which is 4, but let's just keep it this way for a minute. And what's so this is 2 squared, and once again you remember last time when we had something, a product in a parenthesis like a times b or something, and that was squared or something. This is sort of going to be the same thing, because that's 2 squared times 2 squared times 2 squared. And what's that going to be equal to? Well, we have, if we want to rewrite these 2 squares as just 2 times 2, we can definitely do that. 2 times 2, this is 2 times 2, this is 2 times 2. And what happened here? Where we have 2 to the 6th power, because we multiply 2 by itself 6 times. And our main takeaway here is that if we have something in a parenthesis raised to the power of something, then we multiply 2 of these indexes. So this is 2 to the 2 times 3 power, to the power of 2 times 3, which is 6. So this is our main takeaway. So I believe we should do one more of these. If we have 2, let's go with another number now, because we only have 2's here. Let's go with 3. Accidentally erased that one, but never mind. Okay, so if we have 3 to the 4th power in a parenthesis, and this expression is raised to the power of, let's say, 5, then what's that going to be equal to without writing this one? Well, we can multiply 2 of the indexes, and that will be 3, the 4 times 5th power, which is going to be 3 to the 20th power, right? Because we will write this 3 to the 4th power 5 times down. So this is another rule that we have. And now I would like to, I mean, this is sort of the same, but you have a product in this parenthesis, and this is something that we somewhat did last time, because we didn't have, in the parentheses, we didn't have exponents, we just had like normal numbers. So what should we do here? That's our main question. Well, This is raised to the third power, so we should probably just write it then 2 squared times 2 to the fourth power. I mean, we can put out the parentheses, they are essentially not needed, but I'm doing it so it will be a little bit more obvious. Then we have 2 to the second power times 3 to the fourth power once again. So, 2 squared times 3 to the fourth power. We are going to write this one down once again. So we have this, and since it was cubed, we gotta do it once again, because we multiply the expression by itself 3 times. Times 3 to the fourth power, great. And now we would just start rewriting these as sort of just sort of expanding these. It's not called expanding in mathematical terms, but you know what I mean here. So if you would write this in longer form, so 2 squared is 2 times 2, 3 to the fourth power is 3 times 3 times 3 times 3. And if we would do this all the way, we would get 2. How many 2's would we have? 1, 2, 3, 4, 5, 6. So 2 to the sixth power. And this would be multiplied by, well, how many 3's would we have? 4, 8, 12. So that would be 3 to the 12th power. So something I just wanted to show you here is that 2 times 3 is 6, and 4 times 3 is 12. So essentially we can do the same thing as we did up here with a multiple. I mean, sorry, not multiple, with a product. So that's our important takeaway. Now, if we covered this one, we have something else. We have minus. This is also something that kids mess up often. I have actually messed up this a couple of times in my career. And we have minus 5 squared. Now what's the difference between these? Well, I always say that if you want to check it or something, you can just grab a calculator and just check it in a calculator, because I don't believe in maths that you essentially always need a calculator, but I mean, I probably can't screen share this one, but if I would write minus 5, so the top version, this one, I would get in a calculator minus 25. Why? So essentially the reasoning here is that 5 is the number that's squared, and then we just put the negative sign in front of it. But in this case, what is that going to be equal to? Well, that's minus 5, because right now we have a parenthesis, therefore we square the entire thing. So that's minus 5 times minus 5, which is just 25. Because the two negative signs can cancel out each other. So this is something that you should definitely remember. And right now, our last thing that I wanted to cover is, I mean, the last two things is what if the exponent isn't a integer, isn't a whole number, or I mean, it could be an integer, it could be like in our first version we will have 5 to the negative third power. So what do we have here? That's my question. Well, we have a sort of a definition for this. We just do this. What did we do? Well, we got the reciprocal of the entire expression, and that reciprocal kind of, this negative exponent got sort of transferred into this reciprocal exponent. So we keep the exponent, but we, instead of the negative sign, we just write the reciprocal of the number. So if we have 4 to the I mean negative second power, what would that be equal to? Can you guess? Yes, this one. And last one, if we would have 5 to the negative fifth power, What would that be? Yep, once again just the reciprocal of it. So this is pretty cool, because then now we can sort of write up any integer exponent as some expression. So we can evaluate it. But once again, if I probably can't screen share my calculator right now, because like the program I use only records this page. But if I were able to do that, if I always say that you can definitely check these things in the calculator. If I would say 5 to the negative third power, it would be 0 point or comma, whichever you are using, 008. And this one would also be equal to that. According to the calculator, this is also the same thing. So this is just something that you should keep in mind, because once the exercises and the tasks get harder, it's definitely a lot better to know these ones.